Hello and welcome back to Steam It with Steve. Today we're going to continue on with our Introductory to Python course, and we're going to learn about the graphics library called Turtle today. So this is going to be a bit of fun. This is the first bit of like graphical user interface stuff that we're going to learn, and so it's pretty cool. So before we begin, we need to introduce these different control structures that we're going to eventually be looking at. Okay, so there's three different types that you need to learn in any programming language, and that's called sequencing, selection, and then repetition. So sequence is the flow of the program, so the step-by-step instructions that you're following. Selection is when a decision happens, so when you branch out, so you either go this way or this way, and then a loop means that repetition is happening, and it's things are just going over and over and over and over and over. Okay, cool. So just putting that into the back of your mind. So first of all, what does a library mean? So when we think of a library, I always think of a good old books depository where there's multiple books that we can always go along and pick up one that we need. So in this sense, a library has all this information that we don't necessarily need to remember all the time. So when we need to know something, so say we want to learn something about astronomy, we choose that particular book, pick it up, and then open it up, and then we've got that knowledge that we need. The same is true when we code in Python. So a library allows you to use the code that other people have written. So rather than having to remember everything or type out all these instructions, what you can do is you can use a library that you import in that has all that information built in for you. So this saves us a whole heap of time, which is really, really cool. And the way that we do this in Python is pretty simple. We literally just use the import command. So we type import and then we say the name of the library. And as long as it's referenced appropriately, it will come in. Now, Python has a lot of libraries built into it. So today we're going to be using the Turtle library. And it's pretty simple to get all the features of the Turtle library. We literally just type import Turtle. Okay, cool. So first of all, we need to have a bit of discussion. How can Python be used in the real world? So why don't you just have a bit of a pause, have a bit of a think, and then we'll talk through it. Okay, so here are just some of the ideas that I came up with. So the first one is you can do web development. You then can do some game development. There's machine learning and artificial intelligence. If anyone's seen Amazon's Deep Racer, which we'll be doing later, there's a whole heap of stuff in that, which is awesome. There's data science and data visualization, desktop graphical user interface or GUI. There's some business applications, particularly with machine learning. There's some audio video applications, and finally some computer aided drafting or CAD applications. Okay, so these are all the things that you can do with Python that will basically set you up to an intermediate level by the end of this course. So here's a bit of a joke that I found online. So a journalist asked a programmer what made code bad. Right, and the answer was no comment. Right, so commenting is super important when we code. Okay, without comments, we don't know exactly what we're doing. So first of all, what is a comment? Comments look like this. Okay, so in coding, basically with Python, we put a hash at the front. Other languages have other ways of doing it, but with Python, we basically put a hash and then we type. Okay, so comments are used throughout the code to make it a whole heap easier for us to understand what the heck is happening. It's a fine balance though, so you're trying to make sure that the code is readable and makes sense. Is a lot better. And instead of using a whole heap of comments, if you can make the code readable, that's where we want to go as a good programmer, and that's known as refactoring. Then we've got to basically just use the hash. So if you put a hash at the front of any string of text, it blanks out that whole line of code. And it will change the code to red, which means that it's not going to be executed by the program. Okay, so good programmers make sure that the code's super easy to read, so then the next person picking up the code can understand exactly what's going to happen. So from now on, we're going to start having to write our comments in as we're going through because we're going to be good programmers. It is a bit tedious when you first start out, but the simplest way to think about it, imagine someone else picking up your code and they needed to understand what you're doing. So it's pretty important. And it's also useful for you when you come back to your code because you can read the comment and go, oh yeah, that's what I was trying to do here. And it's pretty simple, just put a hash and then write a little sentence after it. We've done this before, just to recap the difference between an interpreter and a compiler. So interpreter is like a conversation where it converts the line one statement at a time. And it's good for very simple programs, which is everything that we've done so far. We've just been typing it in and popping it up. A compiler is a little bit different. So this is like making a book, and it converts all the statements at once. And it's a lot better for good and really big complex programs. So Python's written in an interpreter, and something like C++ or C# runs a compiler where it'll convert all your code into that machine language of the zeros and ones. You can actually still sort of cheat and compile in Python by writing a thing called a script. Now, a script looks similar-ish to Python, whereas basically what's going to happen is instead of doing line by line, you write out everything that you wanted to do, and then it will run it line by line, but then you don't have to physically type it line by line, which is really useful. Okay, now how do you access the compiler? And I'm putting quotation marks to here in Python. It's really simple. Basically, we open idle, we click on file up here, right? And then you will click on the new file and then save the file in a proper location. So just to show you how that would look, if we open up idle here, what you'll see up the top here is the file command. So we click on file, we'll go new file, and then we have our files. Now, to make this work, we need to make sure that we save it in appropriate locations. So when we save the Python file, let's say that we're building an example. So we'll go example. We need to put the file extension .py at the end. If you don't do that, the interpreter, when it opens it up, won't understand that it's a Python style file. So just like when you do Microsoft Documents and you're typing away and you save as a docx, it's exactly the same. So this is the file extension. It needs to have just simply a .py at the name of the file. So we go there, and we'll just put it in documents. So then we've got our file. Now in here, basically if you type anything, so if I go 2 plus 2, and we'll do it properly. We'll go x equals 2 plus 2. And then if I go print x, we've now made our first script. So then you save it and then go up here to run the module, and then it will go off and execute any code. Now, the advantage of doing it this way is instead of writing it line by line, if we want to change something, so instead of 2 plus 3, I want to make it that, we can then go to run and then run the module. The other cool thing is you can press F5, right? And then it will save it automatically and run it for you. Now, this is going to give us a lot more power when we're going to do more complex things, which is where we're sort of going with this. Cool. So we're going to actually use a thing called the Turtle library. Now, the Turtle library gives you access to this graphical platform that's built into all of our Pythons. And what it does is it draws a little turtle pointing to the right. You can then control the turtle, so you can make him move around on the screen. You can then also make him drop a little pen, so he draws a little line as he goes around. And there's a whole heap of exercises that we can do with it. We're going to start with the very basics with this though, okay? So to start, we're going to just use these 4 commands. So the turtle can either move forward, it can move backwards, it can move left, or it can move right. So when we say forward, it's basically going to move the turtle a certain amount of pixels forward in whatever direction that it's currently pointed at. If we say backwards, it will go back in that direction. If we turn, say left, it will then turn left a certain amount of degrees. And if we say right, it will turn right a certain amount of degrees. Okay. Cool. So this is the standard code that we need to write at the beginning every single time that we write something using the Turtle library. Okay, so if you read here, we're going to go import turtle. So then that brings in the library of the turtle. We're then going to create our own turtle. Okay, so what this does here is I go my turtle, which makes a turtle. So this is a variable or an identifier is equal to, and we're going to call inside the turtle library. So turtle dot turtle. Now what this means is it goes to the library turtle and it finds this function that creates a brand new turtle on the screen, which is what this does. Okay, and then it stores that in an identifier that we can then do things with. So if you don't put this next line, my turtle.shape, quotation mark turtle, it won't show up as a turtle, it'll just make it as an arrow. So I've made it a turtle so then it makes it a bit more fun and we can see what it looks like. So to show you what this code looks like, we'll go back to our little example, and inside here, we'll just type that code that I've written across here. So we're going to go import turtle, and then we're going to go my turtle equals turtle with a lower t, not uppercase T, and then capital T because we're calling a function, and then brackets, and then my turtle dot shape, quotation marks, is a turtle. Cool. So now we're going to run that. So Control S or Command S on Mac, and then if you press F5, there's our turtle. Awesome. So we've built it. Now, just to show you what it looks like if you didn't have this line. So I'm going to comment it out, which we all now know is if I put hash and I save that and run it. See how it makes an arrow, which doesn't look as cool. So what this line of code here does in our example code basically changes the shape of the way that the turtle is going to look. Cool. So to make it a bit clearer, that was quite confusing. If I just gave you that code without explaining it, it's not as easy to work out what happened, right? Whereas if I write comments around it, do you see that that makes more sense now? So code to create a turtle, import turtle, makes the turtle available. So there's the library. My turtle equals turtle.turtle, creates the turtle, and then my turtle.shape turtle makes the turtle icon appear. So instead of that, and then hash, write your code underneath this. Now, as a good programmer, it's probably worth actually doing this and getting used to this pattern. So hash is sort of a convention that we use when we want to write something that describes everything that's happening. So it makes it look like a little bit more important for the person reading it. And then this one, what we said, I mean, you don't have to copy exactly what I said, but this is follow brings in the turtle library. This one here was what creates a turtle. And this one here was changes the icon to a turtle. Right. And then underneath here, hash, write your code below this line. Cool. So now we've got the stock standard bit of code that's going to give us, if we save that and run it by pressing F5, it gives us our playground to play around with. Okay. Cool. So as a good programmer, we need to make sure that we write comments for everything. Right. But as we get bigger and better at programming, we don't necessarily, it's like taking training wheels off when you're learning how to ride your bike. It's good to have them on when you start, but you don't need them anymore. Okay, so with this bit of code that we wrote here, probably these lines of code might not necessarily be useful, right? So importing turtle, don't need to necessarily do that eventually. But as we're learning, it's kind of handy just to have them. Okay, cool. So to move the turtle 100 pixels forward, it looks something like that, right? Now to make the turtle do it, so your turtle that you've built, it's pretty simple. We have exactly the same bit of code that we have above it, but now what we're going to do is we're just going to put in the command underneath here for our turtle. So underneath this down here, we just literally go my turtle dot forward 100. Okay, so all this basically up here, you don't really need to understand and remember it anymore. Okay, but this bit here is the command that tells you what's going to happen. So if we save that and run it, there we go. The turtle has started there and it moved across on the screen once. Cool. So then you can do some other cool stuff with that. So we can literally then go, I don't know, 200. So now when we run that, it goes a little bit further. Okay. Cool. So then the next one that we can do is then we can rotate the turtle 120 degrees to the left and then make the turtle move forward 100. So if we open this one up here, if we want to go left, we go my turtle dot left. And if we go to 120 degrees, you just type in 120. And how cool is that as well? In idle, if we type things in with the library, it tells us what we need to import. We need to put an angle and turns the angle left by that many degrees. So we type 120, close the brackets, and then we save that. So now the turtle was there pointing that way, turned 120 degrees and drew it out. Now, there's some really cool stuff with this. You can do turtle artwork, you can draw characters, you can do a whole heap of stuff. This is just sort of the building blocks of your program. So this is what it will look like eventually, and here was the code. So my turtle dot left, 120 degrees, move forward 100 pixels. So you turned 120 degrees and then move forward. Notice that it didn't change anything above this point, right? It was just this point underneath here that was literally doing it. So have a go at this and see if you can do it. So move the turtle so that it creates a square with sides 200 pixels long. So what should happen eventually is your turtle should look something like that. So just pause the video and see if you can do it. Awesome, welcome back. So if we go into our function, where's our turtle example? We have this, right? So the goal is for our turtle to go forward. And it was 200 pixels. And then we want my turtle dot turn left. And then how many degrees are there in a rectangle? Oh, sorry, a square. So if you look at the corner square, that was 90 degrees. So we want to do that. Now I could retype all that, but I'm super lazy. So all I'm going to do is Command C or Control C. And then I'm going to press Command or Control V and paste that underneath. So then it does it 4 times. Now, some of you might already know how loops work. We'll get there eventually. But for now, let's just do this manually and see how that works. So we save that, press F5, and it didn't work. Okay, what did I do wrong? Command. So instead of turn left, it's just dot left. So if we go back here, and it's also lowercase. Whoop. So we do that, and I'm going to copy, going to delete all of that. Right, save F5. Cool. Awesome. And then there's our turtle. He's made the little square. So you can then make some more complex shapes, which is where we're going with this. So the next one that I want you to have a go at, try and create a triangle with sides 150 pixels long. So think about how many degrees the turtle needs to change each time that it goes around. Okay, so just pause the video, have a go, and we'll come back to it so that it should look something like that. Okay, welcome back. So what we're going to do, because I'm super lazy, I'm just going to manipulate this bit of code. So we need it to go 150 pixels long, and we're just going to make it an equilateral triangle. So we're going to go here. I'm going to change that to 150. Now, if we think about how many degrees it needs to go, so it's going to go across first, 150 pixels, and then instead of turning 60 or 90 degrees, it needs to go past 90. So it's instead of an acute angle, look at the math teacher, it's going to go past 90. So it's going to become an obtuse angle of 90 plus the 30 across. Okay, so then that leaves you 60 degrees inside of this part of it, doesn't it? So if you turn 120 degrees each time, it will then come back and make it. So because we know that how many degrees there are in a straight line is 180. So therefore that little bit there is 180 minus 60, which means that we need to turn 120 up the top. Now, because it's a triangle, we need to do that 3 times. So we're going to copy that and we're going to paste it 3 times. Save it and then run it. Done. Triangle. Cool. So that should make somewhat sense. The other thing, you don't necessarily need to rotate it at the end, right? So you just need to do those 5 lines of code. So there's no need to rotate it because you're not going to keep moving along. So just pause the video. Have a read of that first. So move the turtle so that it creates a hexagon and with sides of 100 pixels long. So a hexagon is a 6-sided shape. And think about the logic that needs to happen. So when it comes across, how much degrees does it need to turn each time? So just pause the video, have a go and see how you go. Awesome, welcome back. So we're gonna go back to this and we're gonna have a go with 100 pixels. So we're gonna make him move 100 pixels. And then if we think about hexagon, 6-sided shape, you should start picking up the pattern, right? So instead of it being 6-sided each time, 3-sided, it was 6-sided, which means it's going to be a small degree that needs to turn each time. Okay, so for those that know how hexagons work, they actually have an internal degrees of 120 and an external degrees of 60. So each time it's going to turn 60 degrees. So if we go my turtle dot left, and then we type 60 degrees, and then we need to copy and paste that 6 times. 4, 5, 6. So let's run that one, save it, run it. Cool. Done and dusted. So that's what the code should look like if you've just followed that. Now notice that I didn't have to retype it all out. I just literally copied and pasted. So then the other things that you need to be mindful of, there's a whole heap of other codes that you can use with your turtle. So my turtle can be used to create other shapes. You might want to have multiple turtles, so you don't just need to have one. And these are the things that you can do. So if you do up and down, it actually changes the pen. So you can either make the turtle move and not draw anything. You can then also change the color of the turtle, of the line that's drawn. You can then also fill in polygons. So if you drew that shape and did the fill in color, and then you type in the name of the color inside of a string. So if you say red, you can then say begin fill or end fill. So when it remembers where the starting point is. And then you can also do the stamp, which leaves an impression of the turtle each time. So in this example, if we go back here, if I go, what was it, my turtle, this is kind of cool. Stamp, particularly when we learn about loops. If I run that, see how I left a turtle at the start and then it came back to where it was? That's what the stamp function does. So there's a whole heap here. What I would recommend, play around with those, have a look at the docs. I'll put this in the comments. There's a whole heap of different things that you can do with this, which is a lot of fun. Okay, so there's a tutorial series here called Tracey the Turtle. I would recommend having a go at this. It's awesome. It goes through and shows you how to draw your own name, gets you thinking about what the color could look like, all that different types of things. Okay, so highly recommend that. I'll leave the description in the YouTube down below, and hopefully you can pick up a little bit more with Tracey the Turtle. Awesome. So thanks very much. Hopefully you've learned something about the graphics and how to move around with the turtle. Lots of fun. Play around with as much as you can before you move on from this, because there's a lot that you can learn in this bit of code. So thanks again. See you next time on Same as Steve. Don't forget to like and subscribe, as it helps with our YouTube algorithm. And we'll see you next time. Adios.